Okay, we're on Unit 1, Lesson 15. We are in Chapter 6, Section 6 of the textbook, talking about rational exponents. And our mathematical practice we're going to focus on in this lesson is making sense of problems and persevering in solving them. So previously we've looked at properties of exponents, and what we're going to do in this lesson is write expressions with rational exponents in radical form, and vice versa. And we're also going to simplify expressions in exponential or radical form. So our concept here is something that we've already talked about back in Lesson 13. But if we have a fractional exponent, like some number b to the 1 over n power, you can write that as the nth root of b. We've already talked about that concept. So here's some examples. You have 27 to the 1/3 power is the same as the third root or the cube root of 27, which is just 3. Negative 16 to the half power is the square root of negative 16, which simplifies to 4i. So that's kind of what we're going to be looking at in this lesson. So our first example is on radical and exponential forms. It says we need to write a to the 1/7 power in radical form. And hopefully you are comfortable with the fact that this is just the 7th root of a. Okay, let's move forward. Part B, we're going to write the square root of w in exponential form. And hopefully you remember that the square root is just the half power. So this would be w to the 1/2. Okay, what's our answer here? A to the 1/3 would be, go ahead and advance to the next slide when you have your answer. And obviously this is C. We're going to look at part B. The 5th root of x would be what power? And you have your answer going to the next slide. And clearly this also would be letter A. Okay, for example 2, we're going to evaluate 49 to the negative 1/2 power. And so the first thing that we need to think about is that 49 to the negative 1/2 power, what you can do with whenever you have a negative exponent is you say 1 over that thing to the positive exponent. So negative 1/2 will be 1 over 49 to the positive 1/2. It's based around this property over here. 49 to the half power is the square root of 49, which is just 7. So this would be 1 over 7. That's our final answer. Here's the second way of thinking about that problem. 49 is 7 to the 2nd power, so we could rewrite 49 as 7 to the 2nd to the negative 1/2 power, and then remember that we are multiplying these exponents, and 2 times negative 1/2, half of 2 is 1, so we have negative 1, and 7 to the negative 1 is the same as 1 over 7 to the positive 1, which is just 7, so we also get 1/7 this way. Okay, part B. Getting a little bit more complicated now. We've got 32 to the 2/5. What you're going to want to do when you have problems like this is think about the problem as 32 to the 1/5 power and simplify that expression first, and then raise it to the 2nd power. Because remember, if we're multiplying exponents, 1/5 times 2, that will give us the 2/5 up here. And so if you guys look at the exponent table in the classroom, or if you've written it down or look it up somewhere, or just type this in a calculator, 32 to the 1/5 power is just 2. And so we're raising 2 to the 2nd power, and obviously 2 to the 2nd power is 4. And so while this fractional exponent, it looks like it's going to be difficult from the start of the problem, the problem's actually really easy. Okay, some check your progress problems. Part A, you have to evaluate 25 to the negative half power. When you have your answer, go on to the next slide. And our answer this time is B, 1/5. For part B, we have to evaluate 16 to the 3/4 power. And when you have your answer, go on to the next slide. And our answer this time is 8. Okay, let's move on to our key concept on rational exponents. If we have a fraction exponent, so b to the x over y, that's obviously the fraction is the root, and then we have b to the x power. You can also take that x outside of the root and raise the root of b to the x power. Those things are equal. And you can do that except when b is less than 0 and y is even. Because when that happens, when b is less than 0, when you have a negative number and an even root, you're going to have a complex root in all likelihood. So if you think about this, here's an example. Negative 16 to the 3/2 power, that would be the half power is the square root, and we have a negative number inside. And we know the square root of negative 16 is 4i. And 4i cubed, 4 cubed is 64, and I cubed is negative I. And if you forgot about your I properties, they're written up on the board at the front of the classroom still. All right, example 3, we have a real world problem, and we're going to be looking at something relating to weightlifting. So it says the formula m equals 512 minus 146,230 b to the negative 8/5 power can be used to estimate the maximum total mass that a weightlifter of mass b kilograms can lift using the snatch and the clean and jerk. And the snatch and the clean and jerk are two moves you can do to lift weights. If you don't know about lifting weights, you might want to look those up and see what a snatch looks like or what a clean and jerk looks like. And a mass is just another way of talking about weight. So it says, according to the formula, what is the maximum that a weightlifter weighing 168 kilograms can lift? So the mass, that's B. So you want to throw 168 in here, and then just plug all this in and simplify it, and then you'll get M, and that'll be the maximum weight that the person can lift. So we've plugged in B right here, and it looks like they just took this whole thing and just plugged it in the calculator. And you're welcome to do that, but if you wanted to do it by hand, you would first find the 5th root of 168. And I'm going to pull out my calculator real quick. You guys can't see me doing this, but the reason why, let me write this on the screen now. 168 to the 1/5 power and then obviously we would raise that whole thing to the negative 8 power. But 168 to the 1/5 power is not a whole number. It's 2.78, and then the decimal goes on for many more spaces after that. So 2.78, and that whole thing would be raised to the negative 8 power. And so because this one doesn't come out to be a whole number, that's why they don't show any work. They just dumped this whole expression right here into the calculator. and they got something around 104, or around 472. So basically the conclusion here is that the maximum weight that a weightlifter who weighs 168 kilograms can lift would be 472 kilograms. There we go. Okay, here's one for you guys to check your progress on. We're looking at the same formula, and this time we're going to find the maximum that a weightlifter can lift if he weighs 80 kilograms. So before he weighed 168 kilograms, now he's going to only weigh 80 kilograms. And you want to find what's the maximum weight that this person is going to be able to lift. When you have your answer, go on to the next slide. Okay, our answer this time is C. All right, example 4, we're going to be simplifying expressions with rational exponents. Looks like they went ahead and jumped straight to the answer. So we have to simplify y to the 1/7 times y to the 4/7. And if you look at the exponent properties at the front of the classroom, that poster, you'll see that when you have the same base and you're multiplying, that you add your fractional exponents, you add your exponents. So we have 1/7 and 4/7 makes 5/7. So this answer is just y to the 5/7. And in part B, we're going to simplify x to the negative 2/3. Remember, anytime you have a negative exponent, it's 1 over the problem that you're given. So this would be, if we simplify it, 1 over x to the 2/3. And when you do this, we want to have a positive exponent in the denominator, or a whole exponent. We don't want to have a fractional exponent. So what we're looking at is if this is 2/3, we want to get up to a whole number. So like 3/3 down here, we're trying to get to this. So we know we need to add another third to 2/3. So when to add that extra third over here, what they're talking about, you're going to have to multiply by x to the 1/3. Because 2/3 plus 1/3 will give you the 3/3. But if you do put this x to the 1/3 on the bottom, you also have to put it on the top of the fraction, because then you are essentially just multiplying by something over itself, which is, join toolbar, which is always just equal to the number 1. When you have something divided by itself, that's just 1. If you multiply a fraction by 1, you haven't actually changed what its value is. So then we're going to simplify this numerator. 1 times x to the 1/3 is just x to the 1/3. And x to the 2/3 times x to the 1/3 is x to the 3/3, which is just x to the first power, which is just x. So this is x to the 1/3 over x. So this right here is going to be our final answer. And remember, just because we have a fractional exponent here, you could also write this as, if it's 1/3, it's the cube root. So the cube root of x over x. Personally, I think this looks nicer than this, but you're welcome to leave your answers with a fractional exponent instead of a root symbol. Okay, some check your progress problems. First, we're going to simplify x to the 1/5 times x to the 2/5. When you have your answer, go on to the next slide. And your answer this time is B. We're going to look at part B for checking our progress. We have y to the negative 3/4. Pause the video as long as you need. When you have your answer, go on to the next slide. And our answer this time is letter C, y to the 1/4 over y, or the 4th root of y over y. Okay, we're going to pick up with example 5 in the next video.